Since we're now familiar with structures of both the single-bonded compounds and double-bonded compounds, we can talk a little bit about the concept that is related to this, and is known as bond rotation. If you look at a simple molecule of ethane, which has a carbon-carbon bond, and now we will use this representation which projects the three-dimensional structure on a two-dimensional plane. We can look at ethane, and what we can do, and I urge you to try this with models, is rotate around this single bond. And the way to do this is to hold this part steady while simultaneously rotating the second CH3. And the result of this rotation is a molecule of ethane when the orientation between these two CH3 groups is now changed. So now this hydrogen can be on the bottom. The arrangement is this way. This orientation of ethane is known as staggered, while the alternative is known as eclipsed. And we'll talk about them much more next week. For now, suffice it to say that the molecule of ethane and many other molecules with single bonds continuously rotate around this single bond. So both of these, as well as many intermediate configurations of ethane, exist. So there is no right or wrong one. But if you look at a molecule with a double bond, such as ethene, we know that this double bond consists of a single sigma bond, but then also of a pi bond which connects the top and the bottom of this molecule to each other. Now the rotation around this single bond is forbidden, because if you try this with models, you will notice that in order to achieve the rotation around a single bond, you have to break the double bond, and that of course changes the system we're talking about and is not exactly comparable. And this illustrates something that is a very general rule in organic chemistry, and that is that rotation around single bonds is okay, while rotation around double bonds is not okay, so it's forbidden. In other words, single bonds are flexible while double bonds are rigid. This is also a very good concept to test with molecular models, because it is really hard to substitute anything by just trying these rotations for yourself and feeling the rigidity in double bond and the flexibility in the single bonds.